We are aware of the electrical property of the materials that we come across every day. There are materials that conduct electricity and there are some that do not. Some materials are resistant to the flow of electric current and some are not. The resistance of a material is operationally defined in the following manner. When known potential difference V is applied between the ends of a conductor and the resulting current I is measured, the ratio of V to I is the resistance. The resistance of a material depends on the following factors: the resistivity of the material, the length, and its cross-sectional area.
At this juncture, I will present to you the objectives, material, and the diagram. The objective is to determine the value of the resistance of the fixed resistors using the color-coded technique. The materials or the apparatuses that are being used in this experiment are the 5 pieces of 5 fixed resistors. Furthermore, the resistor color-coded, the 4-band color code, is the common variations. These resistors are 2 bonds for the resistance value, 1 multiplier bond, and 1 tolerance bond.
Procedure. The procedure of this laboratory experiment number 3, entitled Fixed Resistor, begins with the gathering 5 pieces or pictures of fixed resistors. Making sure that the color of the resistors are vivid, we will figure out how to use a color coding method or technique. For the part 5, or the table, first we will mark the different 4 color bands that is present in the resistors. After encoding, we will determine the value of the fixed resistor in ohms. For the part 6 computation, we have to figure out what are the digits that are involved. First band, the second band, the multiplier band, and the tolerance band in order to calculate the value of the fixed resistor. To calculate, we have to use the third and the fourth band. After computing the needed value, we proceed to the following needed explanations or justifications. Specifically, the discussion, observation, analysis, and conclusion.
On this stage, I will explain to you the table and the computation that we have in this laboratory experiment. For the first resistor, we have the value of 4 in the first band, 7 in the second band. For the third band, we have a 10,000, 5% for the fourth band, and come up with a value of 470,000 ohms. The resistor 2 has the value of 5 in the first band, 6 in the second band, 10 in the third band, and 5% for the fourth band, and come up with a value of 560 ohms. The resistor 3 has the value of 5 in the first band, 6 in the second band, 100 in the third band, 5 in the fourth band, and come up with a value of 5,600 ohms. For the resistor 4, we have the value of 3 in the first and second band, and 10,000 for the third band, and 5% for the fourth band, and come up with a value of 330,000 ohms. For the resistor 5, we have the value of 1 in the first band, and 0 in the second band, and 1 million for the third band. And for the fourth band, we have the value of 5%, and come up with a value of 10 million ohms. To calculate the value of the fixed resistor, put the first 2 digits side by side to form a 2-digit number. Example, for the resistor 1 in the preceding figure, the first 2 digits are 4 and 7. Therefore, the 2-digit number is 47. Then, multiply this 2-digit number by the multiplier, and this gives you the nominal value of the resistor in ohm. In the resistor shown in the preceding figure, the 2-digit number is 47 and the multiplier is 10,000. So the nominal value is 47 times 10,000 is 470,000 ohms. In order for you to understand this discussion, the following images are the table and the computation of this laboratory experiment in finding the value of the fixed resistor in ohms.
our discussion simply explains that Ohm's law is a very easy and significant tool for analyzing electric circuits. It is often used in the study of electricity and electronics. Also, it is a formula used to calculate the relationship between voltage, current, and resistance in an electrical circuit. According to an article by Ohm's law, states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. It is used to validate the static values of circuit components, current levels, voltage supplies, and voltage drops. Some tips given for reading the resistor codes: the increased space between band 3 and 4 give away the reading direction. The first band is usually the closest to lead. A gold or silver band, the tolerance band, is always the last band.
Hi, my name is Joshua Daniel Casco, and we will talk about the observation in our lab experiment. For the observation in the first resistor, the first two bands signify that the base number is 47. And with the decimal multiplier of 10,000, the final value of the resistance is 470,000 ohms, or 470 kilo ohms. In the second and third resistors, they have the same base number of 56, based from their first two bands. However, their decimal multipliers are different. In the second resistor has a multiplier of 10, while the third one has a value of 100. This gives out a final value of 560 ohms, or 0.56 kilo ohms, and 5,600 ohms, or 5.60 kilo ohms respectively. Continuation for the observation and analysis. In the fourth resistor, the first two bands signify that the number is 33, and with the decimal multiplier of 10,000, the final value of the resistance is 330,000 ohms, or 330 kilo ohms. In the last resistor, the first two bands signify that the base number is 10, and with the decimal multiplier of 1 million, the final value of the resistance is 100 million ohms, or 100,000 kilo ohms. Based on their fourth bands, all resistors have tolerance of 5%. And that's all. Thank you.
Conclusion. Straight off for the conclusion, therefore, we were able to determine the resistance value of the fixed resistors by observing the color bands, and then color coding them to their respective value. Additionally, the fourth band is also called tolerance band, which represents the value in percentage. I hope that you learned something from us. Just remember always, the important thing is not to stop questioning. Curiosity has its own reason for existence.